Thanks, Nello, for the nice introduction. And of course, I would like to thank the organizers of this workshop, Anna, Maria, and Mario, for inviting me today and to give me the opportunity to talk about what I'm doing in the past few years or so. Basically, what I'm going to do today is to do two things, actually. The first one is to question one of the basic assumptions behind much of the current research in machine learning and pattern recognition. And then I will argue for a holistic perspective for pattern recognition, a perspective whereby, using the famous Gestalt motto, the whole is more than the sum of its parts, and where relational information and contextual information play a more important role than they play today. Given Nello's introduction and given the discussion we had yesterday in the panel, you won't be surprised if the first part will have a light philosophical flavor. So after this first part, I will be proposing, I will be discussing, I will be presenting a new approach for a holistic perspective to pattern recognition, which is based on game theory, more precisely is based on evolutionary game theory. I'm going to address a few problems that we tackled within this framework, in particular unsupervised learning clustering and semi-supervised learning, graph matching, and consistent labeling problems. Okay, so let me start by quoting Satoshi Watanabe, who was a very well-known researcher in the field of pattern recognition. Actually, he was a physicist. He worked with Heisenberg, Paul Dirac, and after a while, he got interested in pattern recognition problems. He was very influential in the 80s, in the 70s, and he wrote exactly 30 years ago this very deep and nice book, which nowadays is kind of forgotten, but I would recommend you as a very nice reading. So basically, Watanabe in this quote basically reminds us that we are kind of all Aristotelians, in the sense that what we do in pattern recognition and machine learning is deeply grounded into an Aristotelian philosophy, whereby the objects that we want to classify and we want to cluster, etc., do possess essential properties. So basically, objects are characterized by essential properties and accidental properties. And one of the goals in pattern recognition is basically to try and find these essential properties. Think, for example, of feature selection. What do we do when we run our favorite feature selection algorithm?